right, everybody. So this lecture is the first in a series on energy and metabolism. So an introduction to metabolism. And metabolism defined is all of the chemical reactions taking place in your cells or in your body. Your body is composed of trillions of cells. Each one has lots of chemical reactions going on all the time. So all of that combined is your metabolism. So for example, you might eat a piece of pizza, right? And it gets digested in your digestive system, which then breaks that pizza up, puts particles of that pizza, the macromolecules into your bloodstream. Those molecules end up going into your cells, where they are then used to extract energy and power your life. I have a worksheet here on the first page that you can come back to and look at and see if you can figure out where to categorize these things. So what I would do is I know you don't know what these words mean yet, but on A, I would put that one as that first bullet point says exergonic, endergonic. Just call this one exergonic and call this one endergonic. Or you could put them down here in the box and then try to figure out where each of these words go, into which box would each of these terms go as you learn the material. Okay, so this chapter is about metabolism and energy. And so let's just first start talking about what happens inside of a cell. Lots of chemical reactions going on in your cell. And unlike a lot of your chemistry experiments where you might mix together chemical A plus B and then you yield chemical C and you're done, we're talking about metabolic pathways a lot of times in this book in biology. And that means A and B might yield C, which then combines with something else to yield D, which combines with something else to yield E, all the way to F, right? So F might be the final product. So the products of one reaction, that's what a metabolic pathway is. The products of one reaction are the inputs of the next. Or the reactants of the next, right? Okay, so that's what a metabolic pathway is. So I want to show you this. Here we have chemical A, and there's a chemical reaction which yields chemical B, which then undergoes another reaction to yield C, which undergoes another reaction to get the final product D. And each step of this reaction, so A to B, has an enzyme that basically makes that reaction possible. And then there's another enzyme for the conversion of B to C and another enzyme for the conversion of C to D. I think of it like this. We have starting molecules, pieces of a car. Enzymes are like the workers that assemble things, okay? So you go from A, you hook it to something else, you end up with B, there's another worker, then you have more parts, you have C, and then you get the final product at the end. Okay, so one thing leads to another until you get the final product. And the enzymes are the molecules making this possible, making the reactions take place. There are two major kinds of pathways from an energy perspective. One is catabolic. Catabolic means we break down molecules into simple ones. Okay, now there's more terminology here, so bear with me. Catabolic, this is when you have a big molecule like glucose and you break it down into CO2 and water. Okay, you break it apart into pieces. And so that is when you go from something big to something small. And when you do that, another thing that is released is energy. And so catabolic talks about breaking down the molecule, but when we think about it in terms of energy, there is more energy here, than there is in CO2, right? And so energy's been released, and so energy's been given off, and the word for that is exergonic. 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 X energy went out. Exergonic. Anabolic reactions are when we build complicated molecules, like when we go from CO2 and water and we build glucose. So this example up here is like cellular respiration. When we break down sugars. This one down here is like photosynthesis. Okay? And energy has to come in for this to work. Like in the case of photosynthesis, we have energy coming in as sunlight. This then is an endergonic reaction. Energy comes in. Okay? So anabolic processes build more complicated things, like this person building a building down here, right? It builds more complicated things and energy is put into it. Whereas an exergonic reaction, like things fall apart, like this building being torn down, and energy is released. Okay? Those are the two major kinds of metabolic pathways. Now, what is energy? Energy is defined simply as the ability to do work or the ability to cause change. That's how we're going to define energy. And what we see then is the definition of metabolism, as I've already said, is all of the chemical reactions in an organism. So those chemical reactions require energy, which is how the two are connected, right? Some of them are going to need an input of energy. Some of them are going to give off energy. So energy is related to these chemical reactions that we're talking about. And so in the case of the windmill, where's the energy coming from? Well, it's coming from the wind, right? That causes change. It causes work to be done. Now here's an example of metabolic pathways in an organism. Look at that. One thing leads to another, which leads to another, which leads to another. If you want to look at a really complicated one, check that out. We're not going to memorize that. But here we can see photosynthesis up here and respiration down below and the interlinking of all the different intermediate chemicals in between. If you're going to go into medicine, you're going to be doing a lot of biochem to learn how some of this works, because this is where your drugs interact with the body and they influence these chemical reactions. All right, so we've talked about metabolism, and we know that energy is involved, the release of energy or the absorption of energy. Let's talk about kinds of energy. So energy is the ability to do work. Now, what kind of energy is, what kinds of energy are there? One kind of energy is known as kinetic energy, and this is the energy of motion. Right? And one kind of kinetic energy is thermal energy. Thermal energy is heat, basically, and it is an example of kinetic energy. It's the random motion of particles. The random motion of particles, and that's what thermal energy essentially is. Okay, potential energy is energy that's stored, has the potential to turn into kinetic energy, right? One example of potential energy is chemical energy, the energy stored in the bonds, the covalent bonds of a molecule, like in a glucose molecule. Another kind of potential energy has to do with position. So for example, let me just look at these guys climbing this ladder over here. This guy at the top has more potential energy than this guy at the bottom. What do I mean by that? Well, if this guy falls off the ladder, he's going to release more energy when he falls and hits the ground than this guy, right? So if you convert potential energy into kinetic energy, this guy's going to produce more kinetic energy and hit the ground harder than this guy. So potential energy is stored energy, either stored in bonds, in chemical bonds, or it can be stored in position, for example. All right, those are some examples of ways you can store that energy. And the thing is, you can convert from one kind to another. You can go from kinetic to potential, and you can come back again. They can be converted from one form to another.